The Monotone hash table collision handler is a subsystem responsible for managing hash collision resolution within the primary data storage layer. This module implements multiple strategies for collision detection and remediation. The system operates transparently to calling code and requires no explicit configuration beyond initial instantiation. Default behavior utilizes linear probing with quadratic backoff for most workloads. The collision handler maintains an internal probe sequence counter that increments deterministically across failed lookups. When a hash function returns a bucket index containing a non-matching key, the handler computes the next candidate index using the established probe sequence. This sequence is deterministic and reproducible given identical input parameters. Probe length is bounded by the table load factor. Load factor represents the ratio of occupied slots to total table capacity. The handler monitors this metric continuously and triggers resize operations when the load factor reaches configurable thresholds. Default threshold is 0.75. When resize is triggered, the handler allocates a new table with double the previous capacity and rehashes all existing entries into the new structure. Rehashing operations execute in background threads separate from primary request handling. During rehash, both old and new table structures remain accessible for read operations. Write operations are queued until rehashing completes. The handler maintains consistency through atomic pointer swaps that occur only after all entries have been successfully migrated to the new table. The quadratic backoff sequence follows the formula I squared plus I divided by 2, where I represents the iteration count. This sequence was selected to reduce clustering patterns common in linear probing. Secondary hash functions are not required by this implementation. The quadratic sequence ensures all positions are eventually visited when the table capacity is a prime number. Deletion operations within the handler employ a tombstone mechanism rather than direct bucket removal. Deleted entries are marked with a special sentinel value indicating a deleted position. This preserves the integrity of probe sequences for existing entries. Tombstones are consolidated during rehash operations when the density of tombstones exceeds a configured percentage of total capacity. Memory allocation for new tables uses a dedicated arena allocator that pre-allocates memory blocks. This reduces fragmentation and improves cache locality. The arena allocator returns memory to the system only when all tables in the arena have been fully deallocated. Allocation failures trigger an exponential backoff retry mechanism with a maximum retry count of 16. The handler exports metrics for monitoring purposes including average probe length, table capacity, occupied slots, and rehash operation count. These metrics are accumulated in thread local storage to minimize contention. Periodic flush operations aggregate thread local metrics into global statistics. Metric sampling occurs at configurable intervals with default interval of 60 seconds. Thread safety is achieved through reader-writer locking at the table level. Read operations acquire shared locks while write and resize operations acquire exclusive locks. The handler implements lock-free reads by utilizing atomic copy on write semantics for the table pointer. Concurrent reads execute without contention, while exclusive operations serialize through the lock. Hash function selection is configurable at instantiation. The default hash function is a 64-bit multiplicative hash based on a well-chosen constant factor. Custom hash functions must be provided as function pointers. The handler assumes hash functions are deterministic and non-colliding for semantically distinct keys under normal conditions. Worst-case lookup time is O of n, where n is the number of entries when load factor approaches 1.0. Expected average lookup time is O of 1 constant. The probe length distribution follows theoretical bounds under random key insertion. Adversarial input patterns may cause performance degradation without careful hash function selection. The handler supports both full and partial table iteration through cursor-based interfaces. Cursors maintain their position across concurrent resize operations by tracking insertion order through linked list pointers. Iteration does not guarantee ordering of entries. Deletion of an entry during iteration invalidates the current cursor position and requires explicit repositioning. Memory overhead per entry consists of 2 pointers plus 1 unsigned 64-bit value. The first pointer addresses the key structure. The second addresses the associated value. The unsigned value stores hash code and metadata flags. Total overhead is 24 bytes on 64-bit systems. Additional memory is consumed by table pointers and capacity tracking. Initialization of the handler requires specification of initial capacity, load factor threshold, and optional custom hash function. Capacity must be a prime number. Supplied capacity is rounded to the next prime by an internal utility function. The handler validates all parameters during construction and raises an error state for invalid input. The handler exposes callback hooks for lifecycle events including table resize start, resize completion, and deletion of final entry. These hooks execute synchronously on the calling thread. Callbacks must complete execution quickly to avoid blocking other operations. Callback registration occurs through a simple function pointer assignment. Shutdown and resource cleanup is handled through explicit destructor invocation. The destructor releases all allocated table memory and deallocates entry structures through registered cleanup callbacks. No implicit cleanup occurs. Long-lived processes must ensure explicit destruction to prevent resource leaks. The handler signals completion through a completion flag readable to external code.